Hello Hako, this is my video for bonus mark 4. I've done the raindrop and now I'm just doing the video to demonstrate Newton's and Aristotle's thinking towards gravity. Aristotle thought that the weight of the object contributed directly to its velocity or its pull on the earth, towards the earth, by earth, gravity, and this was not the case. But it was a good assumption at the time, 300 and something BC. He told everyone that it moves to their natural position and stops. So if you picked up a rock and then dropped it, it'll move to the ground, which is natural position, and then stop, which is right. He said that the weight matters, so a heavier object and a lighter object fall down. The heavier object will be quicker at falling down, he also said that it is proportional. So if something weighs more, it'll go quicker proportionally to the one that weighs less. What else can I say about Aristotle? Pretty good ballpark actually, depending, like, he did live 2,000 something years ago. That was a very good assumption. But Newton, another big influence on what we think about science today. His Eureka moment, well known, was sitting under an apple tree and the apple fell, and he said, why does the apple fall straight down? Must be because the earth is drawing it. Then he came up with the idea that earth has gravity and matter draws matter, and gravity is caused by matter. And to test this, he came up with a couple ideas. He obviously did different experiments, and he came up with the gravitational law, the universal gravitational law, with a constant, which he didn't know at the time, but someone else, I forget the name, did the experiment to find the gravitational constant. Turned out to be 6.673 times 10 to the power of -11. The difference was Newton said that the acceleration due to gravity is constant, but because there is air and resistance and drag, it won't fall at the same time. But if there was a situation where gravity wasn't affected, or the acceleration due to gravity wasn't affected by the drag, and they'd follow the exact same speed and hit the ground at the exact same time if they're released at the same height at the same time. And I'm going to do that today. I already did it once, but because the empty bottle is very light, much lighter than the full bottle, it falls a lot slower, and it actually has drag, or it reaches air resistance, and it stops falling as quick, but it starts the same and then gets slower than the full one. And that also kind of helps my experiment, because now you can see that it actually is the same, and you see air resistance plays a part on the empty water bottle. So yeah, I'll go up, and if Aristotle was right, this one would be much quicker than this one. If Newton was right, then I'd go at the same time, but the air resistance will affect the light one, which you will see. Okay, I'm gonna go up and do it now. Time. So 20 seconds. As you can see, when I drop them, the lighter one and the heavy one at the same time, but as air resistance got up to slowed down the lighter one, out of breath. The lighter one went slower than the faster one, but if there was no air resistance or drag or any of that, they got at the same time. Anyway, hope this shows the demonstration between them, and see you whenever.